Is your Node.js app an open door to hackers? This guide addresses critical risks in production, Node.js apps, secrets leaks, authentication weaknesses, input vulnerabilities, and unsafe dependencies. We'll explore runtime security controls that transform these risks into a hardened, resilient environment. Module 1. Environment variable validation is your first line of defense. Checking for required variables and their formats prevents unexpected runtime failures and security holes caused by misconfiguration or missing secrets. Module 2. Secrets exposure occurs when sensitive data like API keys or tokens are hard-coded, checked into source control, or logged accidentally. Using environment variables and secret vaults prevents this risk effectively. Module 3. Helmet middleware sets numerous HTTP headers to protect your app from common attacks like cross-site scripting and clickjacking. Configuring CSP, HSTS, and its content type options is critical for production security. Module 4. Here's how to apply Helmet with CSP and HSTS headers. This setup enforces HTTPS and restricts resource loading to trusted origins, mitigating XSS and protocol downgrade risks. Module 5. Cores. PSEs define which origins can access your API. A misconfigured open policy risks data leaks and unauthorized actions. Whitelisting trusted origins and limiting methods is essential. Module 6. Rate limiting protects against brute force and DOS attacks by restricting request frequency from clients. Use IP-based limits with burst allowance and blacklist abusive users dynamically. Module 7. Code example of express rate limit limiting clients to 100 requests per 15 minutes, protecting endpoints from abuse while allowing legitimate use. Module 8. Input validation is vital to prevent injection attacks and crashes. Strict schemas and sanitization ensure only expected data enters your system, reducing attack surface. Module 9. Leverage JOI or ZOD for declarative validation. Reject unknown fields and sanitize inputs to prevent XSS, SQL injection, and other common attacks. Module 10. JOI schema, example enforcing username, email, and password with strict validation and no unknown properties, returning errors on invalid input. Module 11. Secure JWT and cookie handling protects user sessions. Setting HTTP only, secure, and same-site flags on cookies reduces theft and CSRF risks. Module 12. Always set JWT and HTTP only. Secure cookies with same-site lax or strict. Use short token expiration and rotate refresh tokens regularly. Module 13. Setting a JWT cookie in Express with secure flags ensures it's inaccessible to JavaScript and sent only over HTTPS connections. Module 14. Dependency auditing is essential to detect outdated or vulnerable packages. Regular audits and lock file verification prevent supply chain compromises and runtime exploits. Module 15. Run npm audit regularly in CI. Commit package lock.json. Avoid eval and deprecated packages to minimize attack surface and supply chain risks. Module 16. GitHub Actions workflow snippet that runs npm audit and fails the build on high-severity vulnerabilities to enforce dependency safety. Module 17. Error handling must avoid exposing stack traces or sensitive data to clients. Use generic messages while logging detailed errors internally with sensitive fields redacted. Module 18. Centralize error handling in middleware, redact sensitive info in logs. Avoid sending stack traces or database errors and client responses to prevent info leakage. Module 19. Error handler in Express that logs detailed information internally but sends a generic error message to the client, protecting sensitive data. Module 20. Runtime hardening involves minimizing privileges, limiting memory, and enforcing strict mode to reduce attack surface and improve reliability under load. Module 21. Avoid running Node.js as root user. Set max old space size to cap memory. Enable use strict for safer JS execution and early error detection. In summary, secure your Node.js production app by validating environment variables thoroughly, managing secrets securely, applying Helmet and CSP, enforcing strict cores and rate limits, validating inputs, securing JWTs, auditing dependencies, handling errors safely, and hardening runtime configurations.